Which of the following is considered to be part of the welding inspector's responsibility to the public? Letter A. Undertaking only those assignments for which the inspector is qualified. Letter B. Making public statements as to the quality of a weldment. Letter C. Signing for all inspections on the job. Letter D. Reporting all discontinuities. Letter E. Verify conformance based on past experience. So letter B is a choice not obligated with the welding inspector. So he's not obligated to make public statements as to the quality of a weldment. Letter C is a little bit too general, so signing for all inspections on the job. Again, it ties to letter A for which the inspector is qualified. So letter D, reporting all discontinuities is not necessary. So an entity specialist will most likely do this depending upon his or her qualification. Letter E, verify conformance based on experience. So this may not exactly rely based on past experience, but the best statement here is that it must conform to the applicable specifications or standards. So the best answer here is letter A. Which of the following processes is performed primarily in the flat and horizontal positions? Letter A, SAW. Letter B, OAW. Letter C, GTAW. Letter D, GMAWS. Or letter E, SW. So if you're not familiar with the acronym, so letter A is submerged arc welding. OAW is oxyacetylene welding. C is gas tungsten arc welding. D is gas metal arc welding, short circuiting, and SW is stud welding. So of all the welding processes here, the only process that can be performed in a flat and horizontal position is submerged arc welding because of its bulky setup. So SAW is also a fully automatic process where a welding operator is assigned since most of the variables inputs are done by the machine itself. Also, the volume of flux deposited in submerged arc is so significant, even if you can configure the machine to do the overhead welding, the amount of wastage for the flux would be so much. So the answer here is letter A. A groove weld symbol with no information appearing to the right means letter A, the weld is to be completed. The weld is to be a complete joint penetration. Letter B, no weld is required on that side. Letter C, the weld is to be continuous for the entire joint length. Letter D, no weld joint preparation is required. Letter E, weld length can be determined by the welder. So it is best to answer this question by showing this figure. So as you can see here, the weld symbol is right up in the center here. So the weld symbol will appear mainly if the weld is on the other side of the joint or in the arrow side of the joint. So this is the center right here. So if you can see the weld length of the weld legend here, so it is labeled as L here. So this is the length of the weld. So if this is omitted, so the length of the weld can be assumed to be continuous for the entire length of the joint. So if you have say a joint that is 3 inches, then if this length of weld is not specified, then it is understood that the length of the weld is also 3 inches. So the answer here is letter C. The weld is to be continuous for the entire joint length.
By the way, I just want to take a break from the video and remind you of the free Udemy course that I've put in the description down below. So it composes of CWI Part A lectures, the introduction for welding inspectors. So you can check out the description below for that free Udemy course. Now back to the video.
The property relating to a metal's resistance to indentation is letter A, tensile strength. Letter B, ductility. Letter C, hardness. Letter D, toughness. Letter E, fatigue strength. So this question pertains to the material properties of the base metal. Letter A is the capacity of the material to resist a force normal or perpendicular to its cross-section. Ductility refers to the ability of the metal to be elongated without breaking. Toughness is the resistance of the material against impact, and fatigue strength refers to the capacity of the material to withstand repeated loads. So the answer here is hardness. It is the property relating the material's resistance to indentation. So the answer here is letter C. LT is the abbreviation for A, leak testing, B, liquid penetrant testing, C, liquid test inspection, letter D, lithium testing, letter E, Lender test method. So the answer here is A, leak testing. So it might be confused with liquid penetrant testing, but the abbreviation for penetrant testing is PT. Leak testing is the answer here. It is a kind of destructive testing that fills in the vessel or a pipe with a medium, commonly water. It may or may not be pressurized depending upon the testing requirements. Of those microstructural constituents listed below, the hardest is A. Martensite, B. Ferrite, C. Bayanite, D. Austenite, D. E. Perlite. So this question can best be answered if you understand this iron carbon phase diagram. So the question is pertaining to which one is the hardest. So this is dependent upon the rate of cooling once the metal is heated. So you can see here perlite, austenite, and ferrite forming at different temperatures. So you can see here this the vertical part of the graph is the temperature. So depending upon their carbon percentage, so perlite and ferrite uh, forms at this range of temperature under these carbon percentages. So what about these choices? So perlite appears at a normal cooling rate, followed by bayanite at a faster cooling rate because the hardness of the metal depends upon the cooling rate in which it is subjected to, and martensite at very fast cooling rate. So typically through a quenching medium. So the faster cooling rates will produce a harder but a more brittle material due to the reduced grain structure. So the answer here is letter A, martensite. So the finer grain structure will be reflected on the material that has undergone a slower cooling rate. Basically, that is perlite. Then the more coarse grain structure is for martensite because of its faster cooling rate. That this constituent will almost always equate to a brittle material. Filler metal specifications are found in which of the following documents? Letter A, AWS A5.1 through A5.30. Letter B, ASME Section 2 Part A. Letter C, AWS A3.0. Letter D, AWS A2.4. Letter E, AWS D1.1 Section 2. For the choices, letter B pertains to the forms of ferrous material products. So that is ASME Section 2 Part A. AWS A3.0 refers to the standard welding terms and definitions. So if you need reference regarding the terms and definitions for welding, it is under AWS 3.0. AWS A 2.4 is for welding symbols, and AWSD 1.1 Section 2 is for structural welding code, and the design of the welded connections under that code. So the filler metal specifications are found in letter A, A5.1 to A5.30. The flux covering on an SMAW electrode produces which of the following? Letter A, gas shielding. Letter B, arc stabilization. Letter C, alloying. Letter D, deoxidation. Letter E, all of the above. The answer here is letter E, all of the above. So the flux covering on the stick welding electrode provides each of these characteristics. So the flux covering provides shielding, which prevents hydrogen from penetrating the molten weld puddle, basically preventing moisture to be captured in the molten weld pool. Arc stabilization, which maintains the arc. Alloying provides different elements in the weld metal, thus providing strength and additional material properties to its betterment. And the oxidation removes impurities, thus removing or thus uh, improving its slag characteristics. So the answer here is letter E. The tensile test can be used to provide values for each of the following. Letter A, yield point. Letter B, ultimate tensile strength. Letter C, modulus of elasticity. Letter D, elastic limit. Letter E, all of the above. So this question can be best explained through a diagram right here. So as you can see here, the Young's modulus or the modulus of elasticity can be found here. The part wherein the stress and strain are still linear right here. Basically, the rise and run are in proportion to each other. And then as it reach a point of somewhere below here, it is the elastic limit below the yield strength. After the yield strength or the yield point, the material will no longer elongate proportionally to the stress applied to it, and then it will go to its maximum or capacity or its ultimate tensile strength right here before it ruptured at its rupture point. All of these points can be determined in a tensile test because basically the material will undergo through this entire stress strain diagram process because the tensile test will ultimately break the material up to fracture. So the answer here is letter E, all of the above. Information that appears to the left of the weld symbol refers to letter A, weld length, letter B, weld size, letter C, electrode size, letter D, number of passes required, letter E, none of the above. So this question can be best explained as well with the diagram here. So the information that appears left of the weld symbol, so again, this is the weld symbol on the center of the welding symbol. So the parameter that appears to the left is the groove weld size or the size of the weld. So upon the choices here, so weld length appears on the right, so that's not appropriate or that's not the correct answer. So the electrode size you don't specify in the welding symbol as well as the number of passes. So the answer here is letter B, weld size.
After a rejected weld has been repaired, re-inspected, and found to be acceptable, the welding inspector should, letter A, change the original inspection report to indicate the part's acceptance. Letter B, mark directly on the part. Letter C, fill out a second inspection report. Letter D, tell the foreman to have the part moved to its next operation. Letter E, no further action is required. So this question pertains to what will the welding inspector do if a rejected weld has already been repaired and found to be acceptable. So letter A, change the original inspection report to indicate the part's acceptance. So maybe this can be done, but this is not the ideal action for this scenario. Letter B, mark directly on the part. So this may be done if the part to be repaired has not been re-inspected yet. So if it will be if it's yet to be repaired, the rejected weld has not yet been identified. Letter D, tell the foreman to have the part moved to its next operation. So to have the part moved to its next operation is not an ideal action in this scenario. Definitely letter E. So you, as a welding inspector, you have to uh, at least document the acceptance of the re-inspected weld. So letter C is the best answer for this question since you the welding inspector feels or fulfills his obligation to document its findings by filling out a second inspection report documenting the results of the re-inspection for the repaired welds. So this is the safe approach here to refill or to fill out a second inspection report to document how the repair weld has been inspected. Also, some standards like API 1104 requires inspection of repair welds by non-destructive testing or even visual inspections, and the records must be kept. So the answer here is letter C. A wire IQI is used in which NDE method? Letter A, UT, letter B, ET, letter C, RT, letter D, MT, letter E, PT. So IQI stands for Image Quality Indicator or penetrometers in the industry. It's also called pennies. So this is the device used to show the quality of the radiographs. So the material for the IQI needs to conform to a standard such as ASTM, and the specification for the whole IQI depends upon the weld thickness. So based from that, uh, it is a device to show the quality of the radiographs. Meaning the answer here is letter C, radiographic testing. So if you're not familiar with the abbreviation or the acronym, so UT is ultrasonic testing, ET is eddy current testing, MT is magnetic particle testing, and PT is dye penetrant testing. The performance of which of the following test methods is least affected by high part temperature? So this question pertains to what testing method is least affected by high part temperature. So basically, after the weld, you can expect that the base metals and welded the welded metal is subjected to a high temperature. So what testing method is least affected by it? So letter A, ET, letter B, RT, letter C, PT, letter D, UT, letter E, VT. So ET stands for eddy current testing and does not need for the probe to touch the metallic specimen. So ET is done by a coil carrying AC and works by electromagnetic induction. So because of this, hot parts are facilitated and allowed. But the limitation of this testing is that highly skilled operators are required to operate and interpret the results. So by that, ET is not affected by the high part temperatures of the weld and the base metal. So for the other choices here, RT uh, is the high part temperatures can affect the result, especially PT and UT because of the need of the contact of the couplant to the base metal or the welded part of the metal. You need to basically have the uh, base metal cool off a bit for safety purposes as well, and of course for visual inspection. So you need to have the metals cool off a bit. So the answer here is letter A. So since the eddy current testing doesn't need contact to the base metal or the metallic specimen, so this is the test method that is least affected by those high temperatures of the base metals. Crater cracks are most often the result of letter A, improper technique, letter B, improper filler metal, letter C, improper base metal, letter D, trap slag, letter E, trapped hydrogen. So this discontinuity is often the result of improper technique because of improper termination leading to insufficient weld metal volume and rapid cooling, causing the shrinkage in the crater area. So the crater cracks are mostly a result of the improper termination of or the welding electrode in contact to the base metal, causing rapid cooling of that point or that area, causing shrinkage. So the answer here is letter A. So the improper technique of the welder most often results with greater cracks. So for the choices here, so what that's why they're not the correct answers is that filler metals in base metal does not cause rapid cooling. It depends upon the heat input. Trap slag causes uh, mainly causes slag inclusion, and trapped hydrogen can cause embrittlement and can eventually lead to cracking as well, but not crater cracks since it does not lead to shrinkage stresses, unlike the improper technique or improper termination that I've just mentioned earlier. So the answer here is letter A. The tail of a welding symbol should not be used for letter A, denoting welding process requirements, letter B, denoting welding procedure requirements, letter C, denoting welding electrode requirements. Letter D, denote welding specification requirements. Letter E, denoting groove angle. So this question pertains to what the tail of a welding symbol is not used for. So it can be, the question can be best demonstrated with this illustration. So this illustration, as you can see here, the groove angle is specified at the top of the weld symbol. This is the weld symbol at the center. So this is the groove angle. So as you can see here, the tail is used for specifying processes or other references. So it can basically specify drawing references, what welding process is it, or among others. Especially indicated here welding process requirements, you can indicate that in detail, even welding procedure requirements, or electrode requirements even, and welding specification requirements. This can be indicated in the tail. But the groove angle has a specified location in the welding symbol. So the answer here is letter E. So denoting groove angle is not a function of the tail of a welding symbol. Which of the following may not be detected with VT or visual testing. Letter A, large surface cracks. Letter B, undercut. Letter C, overlap. Letter D, underfill. Letter E, lamellar tear. So for the choices here, large surface cracks, undercut, overlap, underfill can be detected by visual testing because this can commonly occur in the surface or in the surface of the weld. So large surface crack obviously can be seen visually. Undercut can be seen visually. Overlap and underfills in the joint root can also be seen visually. But lamellar tear, you cannot see it. May not be seen uh, through the naked eye or through visual testing. It is a terrace-like fracture resulting from welding shrinkage, and the three main causes of this are stresses in the through thickness direction, which is parallel to the rolled surface, susceptible joint configuration, mainly for thicker metals. Uh, One of the reasons it may not be detected with VT because of the thicker metals, it may occur underneath the surface and materials with high inclusion content. So eliminating one of those three causes can reduce the susceptibility of the metals undergoing lamellar tear. So the answer here is letter E. Which of the following elements are commonly used as alloying elements with tungsten to produce GTAW electrodes? Letter A, cesium. Letter B, thorium. Letter C, columbium. Letter D, vanadium. Letter E, chromium. So thorium aids in improving the electrical characteristics by making the tungsten electrode more emissive. So basically it makes it more easier to initiate an arc for the TIG welding. So it is most commonly used for joining ferrous metals, hence why it is a common alloying element with tungsten. So if I'm not mistaken, so thorium is added, I think, 1 to 2% with tungsten to have this effect. So the answer here is letter B, thorium. So this is the most common alloying element in producing TIG electrodes. For single bevel groove weld symbols, the line of the weld symbol running perpendicular to the reference line is always drawn on which side of the weld symbol? Letter A on the right, letter B on the left, letter C on either side depending on company policy, letter D on the side in which the straight side actually appears in the joint, letter E doesn't matter. So this question can be best demonstrated by this illustration. So this is a groove, a single bevel groove weld symbol right here. So the line perpendicular to the reference line is this part right here. So the straight line coming through the reference line perpendicular to it. So it is always left of the welding symbol. So it is always left of this one, right? So it's always on the left part of the weld symbol. So the answer here is letter B. So it's always on the left side of the weld symbol. So the portion of the groove face within the joint root is called letter A, weld interface, letter B, faying surface, letter C, groove weld edge, letter D, root face, letter E, groove angle. So the joint root here is the shaded part of this figure right here. So this is where the root face, so this is the root face right here, and the groove face. So this entire shaded portion is the joint root right there. So basically, uh, the part where the groove face is within the portion of the groove face within the joint root is the root face, letter D. So as you can see here, this is the entire groove face, and this part here is the root face and the groove face. Basically, they are on the same joint root. The groove face is the face wherein the groove angle is located. So basically, this is the part of the groove face. This part right here. So the entire part of this one is the root face and the groove face. This is the part of the root face, basically. So the answer there is letter D, root face. Piezoelectricity is a material property used by which NDE method? Letter A, UT, letter B, ET, letter C, RT, Letter D, MT. Letter E, PT. So piezoelectricity is used in UT, wherein the transducer is attached to an electric base unit. The machine then produces pulses through a coaxial cable that is in contact with the test object through the use of a couplant, right? So for letter B, the choice here, eddy current does not make use of contact with the metal, unlike UT with couplant. Hence, it doesn't make use of the concept of piezoelectricity. So RT uses radiographic waves. MT uses magnetic field with ferromagnetic material. So you cannot use MT for stainless steels without the presence of iron. Those ferrous stainless steel, you can use it against that. PT uses the concept of capillary action, which makes use of the developer liquid rising through the uh, crevices of the discontinuity or defect. So the answer here is letter A, UT. A material's ductility is commonly expressed in terms of A, percent elongation and reduction of area, B, width and thickness, C, tensile strength and yield strength, D, toughness, E, fatigue. Ductility, by definition, is a measure of how much the material can elongate before it ultimately breaks. So for the choices here, letter B is just the measurement, so it doesn't really relate to ductility. Letter C, tensile strength and yield strength, is just the ultimate strength and the yield strength and doesn't measure the ductility of the material. Letter D, toughness, is the resistance of material against impact. And letter E, fatigue, refers to the effect of the repetitive loads imposed to the material. So by definition that I've mentioned earlier, ductility is measured by how much a specimen elongates before it breaks, hence the reduction of area here. The higher this ratio, the percent elongation and reduction of area, the more ductile the material is. So the answer here is letter A. Who is responsible for verifying welding procedures have been properly qualified? Letter A, independent test lab. Letter B, contractor. Letter C, welding inspector. Letter D, architect. Letter E, engineer. So this question pertains to who is responsible for verifying welding procedures. So this is normally a job of a welding inspector. So for the choices here, the independent test lab is just responsible for testing the samples and providing a recommendation if it passed or failed. The choice for the contractor here is a bit general. So the contractor can do a lot of things here. So the architect and engineers are responsible for the design and not verifying the weld procedures. So the answer here is letter C, welding inspector. What MT technique could be used for the discovery of longitudinal flaws? So MT means magnetic particle testing. So letter A, coil shot. Letter B, circular magnetization. Letter C, longitudinal magnetization. Letter D, parallel magnetism. Letter E, using a central conductor. So coil shot here is when using a stationary empty machine and electricity passes through that conductor, the magnetic field is created. So longitudinal magnetization is produced from the yoke method as seen here. This is the yoke method. Circular magnetization is used to detect longitudinal flaws. Longitudinal magnetization is for transverse flaws. So if you use circular magnetization, you will not be able to detect transverse flaws, and longitudinal magnetization cannot detect longitudinal flaws. So the answer here is letter B, circular magnetization. Which code gives pre-qualified status to certain weld joint configuration? Letter A, API 1104. Letter B, AWSD 1.1. Letter C, AWSD 17.1. Letter D, NSI B31.1. Letter E, AWS B2.1. So let's just run through the codes here. So API 1104 is for pipelines of oil and gas and petrochemical industries, mainly pertains to the welding of those pipelines. Letter C, AWS D17.1 refers to the specification for fusion welding in aerospace applications. So this is for the airline industry. ANSI B31.1 is for power piping. This is mainly for power plants. AWS B2.1 is for specification for welding procedure and performance qualification. Standard for any other material with no governing specification. But this code does not give pre-qualified status. So if you have any material here that was not being covered by any other welding standard, you can use AWS B2.1. So the only standard or the only code here that gives pre-qualified status is AWSB, AWSD 1.1, the welding code for structural steel. AWSD 1.1 welding code for structural steel gives pre-qualified status to certain weld configuration and is found in its clause 3. So the answer here is letter B. Information that appears to the right of the weld symbol refers to the A. Process to be used, B. Type of electrode to be used, C. Length of weld required, D. Size of weld required, E. Required joint configuration. So let's run through the choices here. So what is the information that appears to the right of the weld symbol? So the process to be used for welding appears in the tail. It is indicated in the tail of the welding symbol. The type of electrode to be used can also be indicated in the tail. The size of the weld appears on the left, not on the right of the weld symbol. The required joint configuration can be indicated in the tail, but the weld symbol kind of implies this joint configuration. So the answer here is letter C. The length of weld required is or does appear in the right side of the weld symbol. The position on a metal stress strain curve referring to its changes in behavior from elastic to plastic is the letter A, yield point, letter B, modulus of elasticity, letter C, endurance limit, letter D, transformation temperature, letter E, Young's modulus. So for letter B here, modulus of elasticity is defined as the stress over strain. It is the slope here, as you can see, the slope of the proportional limit up to the proportional limit here. So it is just the slope of the proportional limit as defined by or as calculated by dividing the stress value over the strain. Endurance limit relates to the allowed repeated loads that the material can take. So if the material is subjected to repeated loads, thus under fatigue, this it can be or the endurance limit must not be reached in order for that material not to exceed its fatigue limit or not to experience fatigue failure. The transformation temperature is just the temperature that the metal will experience during its phase change. And the Young's modulus is basically the same as the modulus of elasticity. So the answer here is the point that uh, where the material changes from elastic to plastic is the yield point right here. So the yield point is where the material changed from elastic to plastic. So meaning if the load experienced by the material exceeded the yield point, it will no longer return to its original form, thus the plastic deformation here. So the answer in this question is letter A, yield point. Low hydrogen electrodes can be properly identified by which digit of a classification number? Letter A, first digit. Letter B, second digit. C, first and second together. Letter D, second to the last digit. Letter E, last digit. So this characteristic can be found in the electrode's last digit. Letter E. It is denoted by numbers 5, 6, or 8, which denotes low hydrogen or the electrodes contain low hydrogen characteristics. So the digits denote different identification for different welding processes. But the notation for low hydrogen content is still in the last digit. So the answer here is letter E. All welding symbols information referring to the arrow side of the joint is found A in the tail, B above the reference line, C below the reference line, D in a note, E to the left of the weld symbol. So the tail denotes other welding information. So for letter A, the tail denotes other welding information such as process, electrode, procedure, even reference drawings you can put in the tail. Above the reference line is for the other side of the joint, not the arrow side. So notes can be done in the tail as well. Left of the welding symbol typically denotes the size of the weld. So as you can see here, the arrow side, if the weld is on the arrow side, right here, it is below the reference line. So the answer here is letter C. Empty or magnetic particle testing can be used effectively to inspect which of the following metals? Letter A, welds on A36 steel. B, steel welds on stainless steel plate. C, welds on aluminum. D, welds on alloy materials. Letter E, materials properly qualified for use with E308 electrodes. So empty can be effectively be used for ferrous metals, in this case A36. So A36 is a kind of structural steel. Welds on stainless steel or welds on stainless steel plate might be problematic, especially for non-ferrous stainless steel because they lack iron. Or for austenitic stainless steels, for example, they don't have iron in itself. So magnetic particle testing will not work on that. Welds on aluminum definitely because iron almost is non-existent on aluminum. That's why it's not rusting, right? Empty will not be effective on inspecting defects or discontinuities in aluminum. Alloy materials here are a little bit vague here, but the rule of thumb is that the material must contain iron for empty to work properly. The last choice here is that E308 electrode is for low carbon material specification. This electrode is for low carbon steels, and this does not relate to the question being asked. So the answer here is letter A. Since empty will work on ferrous or will work effectively on ferrous metals, and A36 is a ferrous metal containing iron. The use of preheat on a medium carbon steel weld test plate will perform all of the following except letter A, reduce distortion. Letter B, reduce the possibility of hydrogen cracking. Letter C, result in the formation of martensite. Letter D, produce a wide heat affected zone. Letter E, diffuse hydrogen. So what happens when you preheat a medium carbon steel? Preheat can reduce distortion since the material will not result in sudden change in temperature. So if you preheat that material, when you weld it, it will not be subjected to a sudden change in temperature due to its exposure to the atmosphere, or if you subject it to post weld heat treatment. So for letter B as well, it will be to reduce the possibility of hydrogen cracking. So the material will have that reduction of possibility because cracks will not happen because preheat will improve its grain property. And because of a larger heat input, basically preheating will have a larger heat input on the material prior welding. It will produce a wider heat affected zone or HAZ. And since we have a larger heat input than normal, it will diffuse hydrogen because the heat will increase the kinetic energy of hydrogen molecules, thus increasing its speed and diffusing them to the atmosphere. So the answer here is letter C, result in the formation of martensite. So preheat will not result in the formation of martensite since these martensite are formed when rapid cooling of metals are done through like quenching as part of making the metal harder, but in its consequence making it more brittle. Martensite makes the metal more brittle because it results in a coarser grain structure when you subject the material in a rapid cooling phase after heating or after welding it. If you see the coarse grain structure that is produced by martensite, if you see it in a microscope, it resembles a broken glass. So it is somewhat synonymous to the metal being brittle. The presence of paint on the surface of a part will most greatly affect the results of which NDA method? Letter A, PT and MT. Letter B, RT and UT. Letter C, MT and ET. Letter D, UT and ET. Letter E, ET and VT. So the presence of paint can affect which of the following non-destructive testing. So that's basically what is being asked in this question. So the requirement of PT and MT is that the weld surface must be clean, and that includes paint. So this presence of paint can cause false indication, and the paint can also block the opening, and thus the discontinuity cannot be revealed properly. So basically, if you have a surface that is being blocked by the paint, then the discontinuity cannot be revealed. So the answer here is letter A, PT and MT. Fracture toughness results often be expressed in terms of letter A, breaking energy. Letter B, tensile strength. Letter C, percent elongation. Letter D, endurance limit. Letter E, reduction of area. So for the choices here, tensile strength is the capacity of the material before breaking. This is indicated or located in the ultimate tensile strength in the stress strain curve, right? So we have it right here. So before the rupture point. So the percent elongation is also known as strain, or the ratio of the length and the original length. So this percent elongation is just basically the strain of the material. Endurance limit is the stress level below which a material can theoretically withstand an infinite number of cycles without failure. So endurance limit basically pertains to the fatigue, or relates to the fatigue failure of the material. Reduction of area is the change in area when the material is subjected to tensile force. So can just imagine if you pull a material in its cross section, and eventually it will be reduced in its area. So the answer here is letter A, breaking energy. So this measures the fracture toughness of a material. So this can be measured by a bunch of testing procedures like CHARPY notch, IZAD, among those testing procedures. If no information appears to the left of a groove weld symbol, this means A, no weld is required on that side. Letter B, the weld is to be complete joint penetration. Letter C, the weld is to be continuous for the entire length of the joint. Letter D, beveling is not required. Letter E, weld size is to be determined by the welder. So when there's a size or a number indicated in the left of a groove weld symbol, it means that the groove weld does not fill the entire joint. So if there's no information, that just means that the weld is a complete joint penetration, which is indicated here in the choice letter B. So for the choices here, A is just false. So there is a required weld on that side of the welding symbol. C, for letter C, there's no information on the right side of the weld symbol. So for this one, if the weld is to be continuous for the entire length of the joint, then it must be located on the right of the welding symbol, or the weld symbol, not on the left. So beveling and the weld size to be determined by the welder is false as well. So the answer here is letter B. So to summarize this question, if it is on the left, if there's no information on the left of the groove weld, then it is a complete joint penetration. If there's no information on the right of the weld symbol, then the weld is to be continuous for the entire length of the joint. The property of a material, the property of a material that best relates to its resistance to impact loading is letter A, endurance limit. Letter B, fatigue strength. Letter C, fracture toughness. Letter D, tensile strength. Letter E, ductility. Endurance limit is the stress level below which a material can withstand an infinite number of cycles without failure. So that relates to the fatigue strength, which is also letter B. So tensile strength is the capacity of the material before breaking, as indicated in the stress strain curve. Ductility is the ability of the material to be deformed or elongate before breaking. So the property here that best relates to the resistance to impact is toughness, fracture toughness. So fracture toughness determines the material's resistance to impact most commonly with high tensile strength materials and for those materials that are exposed to the cold temperature. So the answer here is letter C. Of the following discontinuities, which is most likely to be a flaw caused during the manufacture of steel? A. Porosity, B. Lamination, C. Undercut, D. Crack, E. Inclusion slag. So for the choices here, porosity occurs due to the moisture or the presence of hydrogen in the weld. Undercut is where a notch is formed by a metal being melted away from the weld zone. So a crack is a serious defect that can lead to failure. So as you know, there are no acceptable forms of crack. If you see it, it's automatically a defect. Slag inclusion is the inclusion of a material in the weld metal. So this can commonly be, be formed when there's not enough cleaning in the weld. So for letter B, lamination normally happens when the steel is flattened during the rolling process. So during the rolling process, it can be considered as during the manufacturing process of steel. So the answer here is letter B, lamination. Which of the following is considered to be an advantage of VT or visual testing? Letter A, discontinuities can be located and noted when they occur. Letter B, it is capable of detecting subsurface discontinuities. Letter C, welders can accept their own work. Letter D, equipment can be expensive. Letter E, it can determine material strength. So if you can observe here, all of the choices have their own merits, right? But we have to select the best answer here. So the big advantage of visual inspection is that it can detect a discontinuity before the welder puts on another pass in the weld. Just an example, right? So for letter B here, it is just not possible with the naked eye and without the assistance of other NDT methods. So you cannot detect subsurface discontinuities with your own eyes because it is hidden. So letter C, you want to avoid this. Welders can accept their own work because there must be an oversight with the welder's work in order for a proper quality control procedure to happen. Letter D, equipment can be expensive. So yeah, definitely. Equipment is expensive, but there are other defects that be best done by, for example, X-ray or RT or UT. Just an example. But this is not an advantage of VT because having different NDT methods have their own advantages, right? So this is not the main advantage for visual testing. So because there are other more effective NDT methods that are more appropriate for a specific kind of discontinuity to be detected. You cannot determine the material strength by just looking at it. So you have to, it needs to be tested or uh, for example, tense or it must be subjected for under a tensile strength machine. You cannot determine it by just looking at it. So the answer here is letter A. Discontinuities can be located and noted when they occur. So that gives value to the uh, welding procedure or welding the entire welding procedure because you can detect the early signs of failure before it even or before it got it will be hidden because another pass of weld is done. So you can do that by having a hold point in the inspection test plan if that weld is to be a critical one. When a weld has been rejected by a qualified NDE technician, the welding inspector should letter A, review the test results and maintain the test record. Letter B, reinspect to verify the defect. Letter C, accept the weld if its visual appearance is in compliance with the applicable code or specification. Letter D, require another inspection by a third party. Letter E, accept the weld since it is in a low stress region. For letter B, no need to inspect if the weld has already been rejected by a qualified NDT technician. So this is just counterproductive already. So letter C, this is a big no because the code will not allow this in the first place. Because the first basis of weld acceptance are actual measurement of the discontinuity as you see it in the weld. Letter G is just expensive and unnecessary. So you don't need another inspection by a third party unless otherwise you have a dispute with the first NDA inspector. So that's just not very efficient or very cost effective. And letter E, we don't have enough information for letter E to be true. So the answer here is letter A. So this goes back to the responsibility of the welding inspector to review the test results done by the NDT technician and maintain the test records. So if there are any disputes or, for example, any code violation or whatnot that has been reviewed by the welding inspector, then he should take it up with the NDT technician. But if it is all good, because it is not stated in the question that there are any discrepancies, so the best answer here is letter A. If equal thickness of steel, cast iron, aluminum, lead, and copper are radiographed using the same exposure conditions, which material will result in the darkest radiograph? Letter A, lead. Letter B, steel. Letter C, aluminum. Letter D, copper. Letter E, cast iron. So this question will test your knowledge of the output of these radiographic films. So the less dense material will produce the darkest radiograph. This is why hollow points in the radiograph are also the darkest. Hence, there's discontinuity there. So if there are lighter points that you see there, lighter indications, so that means there are discontinuity, right, in the film. So if you are familiar with the densities of these materials, so you can know that the least dense out of all the materials here are or is aluminum. So the answer here is letter C. So the least dense material will produce the darkest radiograph among these choices. All welding symbols require which of the following basic elements in their construction? Letter A, reference line, arrow, and tail. Letter B, reference line and arrow. Letter C, reference line, arrow, and weld symbol. Letter D, reference line, arrow, weld symbol, dimensions, and supplementary data. Letter E, reference line only. So the only necessary elements of the welding symbol are the reference line and arrow. All others are just optional. You cannot call a welding symbol without these two elements. So the answer here is letter B. Of the welding processes listed below, the one most commonly having the highest deposition is A. OAW or oxyacetylene welding. Letter B. FCAW, flux cord arc welding. Letter C. SAW or submerged arc welding. Letter D. SMAW. Letter E. GMAW. So the answer here is submerged arc welding, SAW. Because out of all the welding processes, this has the largest deposition because of its setup and the characteristic of this process, as it is an automatic welding process, unlike the other welding processes that you can see here, which is either manual like SMAW or GMAW, which is a semi-automatic process, and FCAW as well. So SAW is also operated by a welding operator, not a welder, which is aligned to be it becoming or to be it being in to be with it being an automatic welding process. So the answer here is letter C. The size of the weld represented in the figure below. A is not important. B cannot be determined directly from the symbol. C can be determined from the symbol. D is not specified, therefore may be determined by the welder. E must be found in the WPS. In this question, as you can see, the welding symbol does not have any indication of the number at the left of the welding symbol right here. So it doesn't indicate anything. Therefore, the answer here is letter B. The size of the weld cannot be determined in this welding symbol. Letter A does not make sense. Letter C is obviously incorrect. Letter D, if the welding symbol is not clear, the welder will definitely ask for the size here. Letter E, the size of the weld may or may not be found in the WPS. So the answer here is letter B. Welding symbol information provided in the figure below requires A. Field welding, B. Weld all around, C. A felt weld, D. The use of shielded metal arc welding, letter E. All of the above. If you can observe the welding symbol here, so this symbol is the symbol of a fillet weld. This flag right here is a symbol for field welding. The circle right here is, or the circle right here represents weld all around, and the information indicated in the tail is SMAW, which means shielded metal arc welding. So the answer here is letter E. A shielded metal arc welding weld has produced in which the welder failed to properly clean between passes in a multipass weld, which non-destructive test would best reveal the flaws that may be present in the completed weld. ART, BVT, CMT, DPT, letter EET. Since the welder failed to clean passes in between weld in a multipass weld, this indicates that the flaw will likely to have occurred in the subsurface of the weld. Visual tests will have no use in subsurface flaws. You cannot see that by the naked eye. MT and PT are for near surface discontinuities. ET is also for near surface. The only NDT here that can detect subsurface flaw here is RT. Hence, the answer here is letter A, radiographic testing. Which of the following welding techniques below describes a welding process in which the filler metal feeding is machine operated while the joint travel speed and guidance are the responsibility of the welder? Letter A, semi-automatic. Letter B, machine. Letter C, manual. Letter D, automatic. Letter E, mechanized. Machine, mechanized, and automatic welding are synonymous in which every parameter can be done without welder supervision. Hence, machine and mechanized welding have welder operator and not a welder. So because it basically operates a machine. Manual welding, the welder will have to control all parameters including wire feed speed because he basically will replace the electrodes once it was being consumed. Semi-automatic like GMAW, FCAW are the ones that the wire feed speed is operated by a machine. Basically, it is the wire speed is controlled by a reel. Hence, the answer here is letter A, semi-automatic. Arc strikes are discontinuities most commonly associated with A. ESW, B. SAW, C. SMAW, D. OAW, letter E. GMAW. Arc strikes commonly happen in SMAW or stick welding since this is mainly a welder error or a bad habit that the welder do prior striking the weld metal. They strike the surface to test and may lead to this discontinuity. So it is a common welder behavior wherein they strike the surface and thus cause this arc strike discontinuity. A and B are automatic process, so this will not happen. ESW and SAW. OAW is operated by a torch, which likely won't happen. GMAW can have arc strike occur, but not as much as SMAW. So the answer here is letter. So the answer here is letter C, SMAW. Liquid penetrant testing is not recommended when inspecting which of the following metals? Letter A, aluminum plate that has been chemically cleaned. B, steel weld test plates brushed. C, stainless steel pipe as welded by GTAW. D, a casting that has been sandblasted. A and B is okay, and B is even recommended prior dye penetrant testing because basically you have to clean these weld surfaces in order for dye penetrant testing to be accurate. So it basically keeps the opening of the surface which is necessary for capillary action. C is also good since austenitic steel can still be detected by PT. So if you're using magnetic particle testing for austenitic stainless steel, you can do that because it can't be magnetized. The answer here is letter D. Since sandblasting breaks off or pin the surface that can close necessary opening in the surface necessary for capillary action. So if you sandblast the surface of a metal, basically dye penetrant testing will not be possible because you basically broke off all the openings there that is necessary for the capillary action or the liquid coming or rising to the surface to occur. So the answer here is letter D, a casting that has been sandblasted. Which of the following discontinuities is not associated with GTW? A. Lack of fusion. B. Slag inclusions. C. Tungsten inclusions. D. Porosity. E. Undercut. All of the discontinuities mentioned above can happen to GTAW except slag inclusion. Letter B. Since GTAW is very much a clean welding process with little to no slag produced during the welding process. The answer here is letter B. An E71T-1 electrode designation is for which welding process? Letter A, PAW. Letter B, FCAW. Letter C, SMAW. Letter D, GMAW. Letter E, SAW. So the answer here is letter B. The designation T here means tubular, which is the electrode description for FCAW or flux cord arc welding. So the answer here is letter B. What is meant by the term essential variable? Letter A, data on a WPS that if changed during production will render a WPS disqualified. Letter B, data on an inspection report that if changed render the report disqualified. Letter C, the data on an MTR or material test report that is essential to the chemistry of the material. Letter D, the recommended amperage and voltage for welding as published by the manufacturer. Letter E, describes what should be included in a WPS. So let me run through the choices here. So letter B and C is an automatic elimination of the choices since this essential variable refer to the WPS. WPS can indicate the recommended amps and volts for welding, but this is not the definition of an essential variable. So basically, you can indicate the recommended amperage or voltage from the welding as published by the manufacturer, but this is not the definition of an essential variable. Letter E, those are not just what's needed to be included in the WPS. So the answer here is letter A. If these essential variables change, then the WPS will be disqualified and you will need to requalify the procedures indicated in the WPS again. So you'll need to retest those procedures that was done or the results of the procedures that was done during the original WPS and the variables that was changed. Where should the preheat temperature be measured? Letter A, in the weld groove. Letter B, 12-inch from the weld groove. Letter C, where the arc will be initiated. Letter D, 2 to 3-inch from the weld groove. Letter E, preheat temperature need not be measured. So the preheat temperature needs to be measured 2 to 3-inch from the weld. So the answer here is letter D. This is because this is where the HAZ or heat affected zone is, wherein the highest susceptibility of martensite formation can happen. So what does that mean? So HAZ refers to the portion of the base metal that has been heated to high temperature but not melted. So when it cools off, it basically the base metal undergoes a microstructural change that can affect its mechanical or material properties such as strength and toughness. So martensite formation can lead to the brittleness of the base metal, which we don't want that. So when no preheat is used, HAZ is relatively narrow and will exhibit the highest hardness. So as a welding inspector, you need to inspect the preheat temperature at the HAZ or in the heat affected zone because this is where the highest brittleness will happen. This is why this is the location where the preheat temperature must be measured to ensure that effective slowing down of the cooling rate happens in the heat affected zone, because essentially that is what preheat does to the base metal. So it slows down the cooling rate of the base metal, hence will slow down also the formation or prevent the formation of martensite, hence prevent brittleness of the base metal. Letter A, always rejectable. Letter B, never rejectable, but its condition should be noted in the inspection report. C, always a defect. D, an indication that renders a part unusable. E, an interruption in the uniformity of a weldment. So remember this when noting of the difference between a discontinuity and a defect. So a discontinuity is not always rejectable because it is not considered a defect, but a defect can be considered as a discontinuity. Since a defect is also an interruption
of the uniformity of a weldment. So it is just a matter of whether this interruption is acceptable or not per the code or standard that this weld is adhering to. So letter A, always rejectable, is not true. So a discontinuity is never rejectable, so it's not true as well, because if it's not acceptable, or if that discontinuity is considered a defect, then it is rejectable. So a discontinuity, as noted, as I've just said, so it's not always a defect. An indication that renders a part unusable, so that's not true as well, because that letter D is synonymous to letter C. And the answer here is letter E, an interruption in the uniformity of the weldment. So that is the most accurate or apropos description of a discontinuity. Which of the following discontinuities can be caused by poor welding technique? So letter A, incomplete fusion. Letter B, porosity. Letter C, undercut. Letter D, overlap. Letter E, all of the above. So the answer here is letter E. So all of the above discontinuities can be caused by poor welding technique. So all of them can be caused by a welder that is not following the proper procedure, or not uh, doing the proper technique of welding. If a welder is continually turning out rejectable work, the welding inspector should: letter A, inspect his work more critically. Letter B, ask that the welder be terminated. Letter C, require requalification. Letter D, instruct the welder in proper techniques. Letter E, ask that the welder use another process. So if the welder continuously turning out rejectable work, that is a good enough reason for him to be requalified. So the answer here is letter C. So some codes have timelines for a welder. For example, if that welder have not worked on a specific welding process, like for example GTAW or FCW, to name a few. But codes do in fact have stated that if a welder demonstrates reason for him to be requalified, like turning out rejections after another, then this is perfectly justifiable to require him of requalification. So letter A, inspect his work more critically, can be subjective. It's not an effective way of objectively determining if that welder is has the skills for that welding process, other than requiring, of course, requalification. So letter B is a draconian or a nuclear solution, immediately terminated. So that's not what the code says. So instruct the welder in proper technique. So how would you objectively uh, do that? So it goes back again to letter C. So ask the welder for to use another process is just not applicable to this. So the answer here is letter C. Which discontinuity occurs in the heat affected zone and can result from excess moisture in the weld zone? Letter A, throat crack. Letter B, crater crack. Letter C, underbead crack. Letter D, porosity. Letter E, centerline crack. So let's run through the choices here. So throat crack occurs along the center of the weld face caused by excessive joint restraint. So if you have a weld there that is, or you have a weld here that is basically restrained by unyielding supports. So that doesn't allow the joint to expand slightly because of the heat that is being applied by the weld. So that causes throat crack. Crater crack are hot cracks that occur because the arc is broken too quickly, cooling and solidifying the weldment and producing a crack. So for example, you don't have proper arc length control of the weldment. So you basically broke the arc too quickly, thus cooling the weldment too cool, thus render it become rendering it becoming brittle. So that will solidify the weldment and produce a crack. So porosity is caused by moisture in the weldment. Centerline crack is basically similar to letter A. So what the question asked for here is it occurs in the has or in the weld zone. So not basically in the weld itself, but in the heat affected zone. So you have a weld there, for example. So this is the weldment here. So you have a heat affected zone that is basically some distance away from that weld. So you have a heat affected zone here, and the underbead crack occurs there. So So the answer here is if you can eliminate all of it, so all of these defects occur in the weld itself, but not in the has or in the heat affected zone. So the answer here is letter C. So it's the only defect here that occurs in the heat affected zone. So that's the answer there. Which of the following is not a type of weld joint? So letter A, lap, letter B, T, letter C, fillet, letter D, butt, letter E, edge. So though commonly coined as fillet welds, it's not a type of joint. So the five common types of joints are lap, T, corner, which is not in these choices, butt, and edge. So the answer here is letter C. A single wire submerged arc welding machine is operating at 32 volts and is traveling at 8 IPM. What is the heat input for this situation? So here are the choices here. So if you're familiar with the heat input formula, which is basically just voltage times current over the travel speed. So, but if you don't know that, so you can basically do some unit analysis here. So if you multiply voltage times current, that produces power, which is watts or joules per second. That is joules per second. So if you divide that by inch per minute, inch per minute, and you basically multiply this by 60 seconds per minute. So if you multiply it by that, then you basically have the unit as seconds, you cancel that, minutes, you cancel that, then you have what remains here, joules per inch. So you will notice that this will yield the right answer. So if you multiply 32 volts times 600 times 60 divided by 8, that will give letter C, 144,000 joules per inch. The pipe welding test position in which the axis of the pipe is horizontal and the pipe is rotated so that the welding takes place at or near the top is designated as letter A 2G, letter B 2F, letter C 1G, letter D 3G, letter E 6GR. So the answer here is letter C 1G. So if you're basically rotating the pipe so that you can weld that that joint at or near the top, then you basically it's just 1G. So that's the answer there. So when establishing a PQR, the type and number of tests required is determined by the applicable standard. Letter B, a face and root bend will qualify all plates. Letter C, testing requirements are determined by the contractor and approved by the inspector. Letter D, destructive testing is required only if a problem is suspected. Letter E, a weld test plate does not have to be mechanically tested to establish a PQR. I think reading from the choices, you'll definitely have the hunch of which is the correct answer here, because if you can see the choices, the most reasonable, or you can almost determine the most reasonable ones here, because if you, for example, the all encompassing choice here, like qualify all plates, does not have to be tested, so that's mainly basically a draconian or a nuclear choice, or an extreme choice that is over encompassing every scenario that is being thrown at you here. So that will probably not be the correct answer. So let's run through all of them. So letter B is not true, since a standard shall determine the qualification. So a face and root bend will qualify all plates, not necessarily. So it depends upon the standard. So letter C is similar. Again, the contractor owner or even the inspector does not dictate this. It's the standard. So the inspector is just following the standard. Destructive testing is required per standard whether a problem is suspected or not. So if the standard, for example, requires you to hydrostatic test that weld or impact test that weld, for example, for structural welds or for pressure welds or for welds that has if you were welding high stress materials which may require impact tests, then you have to do them. So it's not just when a problem is suspected. So letter E, again, it depends on the standard. So if the weld test plate have to be mechanical tested or not, so it's not always the case. So the answer here is again letter A. So it depends upon the standard. So the type and number of tests required is determined by the applicable standard. So which of the following measurements are taken from a tensile specimen to determine area? So letter A, mass and volume, B, length and thickness, C, width and length, D, width and thickness, letter E, load and pressure. So if you're looking to determine the area based from a tensile specimen, so you basically have to pull them, right? So you have a testing machine here and you have to pull them. So you need to determine the load, the force basically, and the pressure in which, or the stress capacity of that material there, that in order for you to determine the area here. So that's the answer here, letter E. So it's not enough for the width and thickness, width and length. So because you're having a tensile specimen there, so you need the load and pressure there. Which of the following conditions can cause lag inclusions in a weld? Letter A, insufficient groove angle in an SMAW single V groove weld. Letter B, careful interpass cleaning of subsequent layer and beads of FCAW. Letter C, insufficient preheat of test plate. Letter D, insufficient shielding gas flow in GTAW. Letter E, improper fit up of GMA test plates. So, insufficient groove angle due to its narrow space can often lead to slag being left in the puddle. So that happens in SMAW. So if you have insufficient groove angle, the tendency there is you have a constraint small area there that most likely that slag will be left there if you have insufficient groove angle because of the tightness of that area. So if you're doing careful interpass cleaning, of course, you will uh, reduce the chances of slag inclusion. Insufficient preheat of test plate is not relevant here because it affects the brittleness of the material. Insufficient shielding gas flow in GTAW. So GTAW does not produce slag. So uh, it's tungsten inclusion, not slag inclusion. Same with letter E. So it doesn't produce slag there or minimal, just minimal production of slag there. So the answer here is letter A, sorry. So this is should be letter A. The heat treatment for carbon steels in which the metal's temperature is raised to just below the lower transformation temperature and held for a prescribed time before allowing it to cool at a controlled rate is referred to as letter A, tempering, letter B, austenitizing, letter C, stress relieving, letter D, normalizing, letter E, preheating. So this question refers to a very general term in terms of heat treatment. So let me run through all the choices. So tempering improves the hardness but in a much controlled manner than quenching, which improves ductility and reduce brittleness. Austenitizing refers to where ferrous alloys are heated to transform them into austenite. Normalizing is heat treatment in still air. So for example, if you have or you are heat treating a metal into an oven or into a furnace, then you open that oven's door or panel, then that is basically normalizing because you're allowing still air to improve the ductility, but not as much as annealing. Preheating reduces cooling rate, thus improving properties and preventing the potential for cracking. So this preheating, you basically improve the amount of or reduce the cooling rate, thus improving the properties of the metal, preventing it to become brittle. So the answer in this question is it is a more general term here is stress relieving, letter C. So stress relieving is a general term for allowing metal to cool in a controlled rate. Next question. Electrical conductivity of a part is the primary requirement for which NDE method? Letter E, letter A ET, letter B UT, letter C PT, letter D RT, letter E VT. Electrical conductivity is a main part of eddy current testing, which is the answer here, letter A. So UD or UT or ultrasonic testing makes use of a high frequency sound waves. PT makes use of capillary action to detect cracks or pores. RT uses X-rays or gamma rays to detect internal flaws or subsurface flaws. VT just is a visual testing, which makes use of our naked eye or with an aid of an instrument to detect surface flaws. So the answer here is letter A. Decibel is a term associated with which NDE method? Letter A, UT, letter B, RT, letter C, MT, letter D, PT, letter E, ET. UT makes use of sound waves, so that's why in ultrasonic testing decibels are used. So the answer here is letter A. So RT output is visualized through films. Magnetic particle testing or MT makes use of magnetic particles. PT makes use of developer liquid, and electrical conductivity is the main property used for ET. None of which these four choices makes use of decibel as a term associated with them. Thus, the answer here is UT or letter A. Developing is one of the steps in which NDE method? Letter A, UT and ET. Letter B, RT and PT. Letter C, PT and MT. Letter D, MT and ET. Or letter E, VT and PD. So if you're familiar with those NDE methods in which in the part A of the exam will most likely appear, so developing is part of radiographic testing and penetrant testing, which is letter B, because it is developing is important or part of the film production or the generation of image in the films, and the development of and the developer being applied to the penetrant testing is part of course PT, which the answer here is letter B. If the weld symbol straddles the reference line, it means A. Weld both sides, B. Weld arrow side first, C. Weld other side first, D. Weld has no side significance, E. The symbol has drawn incorrectly. So the answer here is letter A. So if the weld symbol straddles the reference line, so this is the reference line here, this line right here. So if the weld symbol straddles the reference line like so, then the weld symbol indicates that the weld has to be made on both sides of the joint. So the answer here is letter A. In which direction does a rolled plate of carbon steel usually exhibit its least amount of ductility? Letter A, parallel to the rolling direction. B, transverse to the rolling direction. C, in the through thickness direction. D, in the direction of welding. E, in rolling direction has no significance regarding ductility. So this occurs in the through thickness or in the z-axis of the plate, meaning the thickness of the plate, and inclusions because the alignment of grains in this thickness, so in this thickness of the plate right here, makes so that the alignment of grains and inclusions such as sulfides and silicates make it susceptible to lamellar tear. So lamellar tear occurs normally at this location, at this through thickness of the plate due to high localized stress and because it is the area of the material or the plate which exhibits the lowest amount of ductility, making it susceptible to that high localized stress there, which in this instance is the lamellar tear. So the answer here is letter C. Which of the following welding processes commonly use a constant current power source? Letter A, GMAW and FCAW. B, SMAW and GTAW. C, GTAW and GMAW. D, FCAW and SMAW. Letter E, SAW and SMAW. So SMAW and GTAW are constant current power source because a significant change in voltage in these processes can occur through a slight or very little change in the current. So since the heat input or is a function of voltage, current, and the travel speed, or since the heat input is a function of voltage, current, and arc length, the welder can control this heat input by controlling the arc length. So for example, the amount of distance that this tip of the electrode is spent on that weld puddle or that molten puddle, so he can control, the welder can control them because it is a function of that and the amount of current that is being produced through the welding machine. So for example, just a small adjustment in the arc length can also affect the amount of electricity that is being put through in this welding electrode, thus adjusting the heat input towards the molten puddle. That is why improper control of this arc length for these types of processes can severely affect the quality of weld that is being produced here. So the answer here is letter B. In order to learn the exact location of a subsurface flaw in three directions, the best NDE method would be letter A RT, letter B MT, letter C PT, letter D UT, letter E VT. UT or ultrasonic testing is the best method to detect subsurface flaw in three directions. So the answer here is letter D. This is why sometimes RT can be limited in detecting planar flaws which occur in three directions and also may be limited on detecting flaws on thicker metals, whereas UT can do the job. So for example, if you're looking for subsurface flaws on a thicker metal, RT may not be able to do the job, and UT can is the most appropriate NDA method to do just that. So the answer here is letter D. Which of the following welds is not considered applicable for a butt joint? Letter A, V groove. Letter B, plug. Letter C, edge flange. Letter D, U groove. Letter E, J groove. So one clue here is that all of the groove welds are applicable for a butt joint. So letter A, letter D, letter E is considered applicable for a butt joint. So all of the groove joints can be applicable as a butt joint, including the edge flange here, because it can be considered as a butt joint as well because of its configuration. Hence, the answer here is letter B. Plug weld involves welding two pieces of metal by filling drilled holes with weld, hence a plug. So it is commonly used in instrumentation connection if you're planning to seal a weld there. When using SMAW, wet electrodes will most likely cause letter A undercut, letter B overlap, letter C underfill, letter D porosity, letter E all of the above. So the answer here is letter D. So this is why electrodes shall be properly maintained in their appropriate oven temperature. Wet electrodes can cause moisture in the weld puddle and can cause porosity. Porosity is just hydrogen, oxygen, and nitrogen trapped in the weldment. So if you have a weldment there and basically this electrode is wet or this has moisture, this is a wet electrode. Basically, you're putting more uh, hydrogen, oxygen, and nitrogen trap, or basically you're putting those elements in the weld puddle, because essentially moisture is just a combination of hydrogen and oxygen, H2O. So then porosity will likely happen if you're using wet electrodes. So it is important that appropriate maintaining oven temperature is being used when, you, for example, you're at site and you're opening the or you're exposing the electrodes to the atmosphere. So it's important that you keep it on an oven. So it is important as well. I had experience when I was working in the oil and gas industry. So I also keep in mind that the contractors or the person or the personnel that is doing the job is keeping these electrodes in their appropriate storage temperatures. So it's some sort of a preventative measure to ensure that their output or their weld output or their weld production is being will be ensured that it is of utmost quality, preventing such defects or discontinuities. So the answer here is letter D. Porosity and GMAW can be caused by letter A drafts, letter B contamination, letter C too little shielding gas flow, letter D too much shielding gas flow, letter E all of the above. So the question being asked here is porosity, which can be a discontinuity in this gas metal arc welding process. So drafts can cause drafts can cause porosities. Drafts just another term for wind. So that's why if field welding is done, proper protection against the elements must be incorporated, like tents or humpies, something like that. Contamination can also cause porosity, not just in GMAW. So if you have like dirt or whatever contaminants in your weld puddle, that will cause porosity as well. Too little shielding gas can cause moisture and unwanted gases to penetrate the molten puddle, thus causing porosity. So if you don't have enough shielding gas flow, so the weld puddle will not have enough protection to deter all the gases coming in that can be detrimental to the weld process. Also, too much shielding gas flow can cause porosity. So why is that? So if you have too much of a flow in there, it can create vortex that induces vacuum conditions around that weld puddle in there, and that will cause it to suck the gases into that weld puddle and will cause porosity later on. So too much is also not good. It should be the right amount as specified in the welding procedure specifications. So the answer here is letter E, all of the above. Which of the following are common causes of undercut when using SMAW? Letter A, weld current too high. Letter B, improper electrode manipulation. Letter C, welding electrode too large. Letter D, improper electrode angle. Letter E, all of the above. The answer here is all of the above, since undercut results from melting away of the base metal from the toes of the weld and left unfilled. So for letter A, weld current too high gives more heat to the point of melting the base metal. So if your weld current is too high, it equates to more heat basically. So the tendency is that the base metal will be melted because of that high heat input. Improper electrode manipulation. So too short a distance from the base metal can melt it, and improper manipulation can also left it unfilled. Large welding electrode will tend to melt the metal more because of its size. Improper electrode angle or work angle can affect proper weld deposition and can cause melting away of the metal. Thus, the answer here is letter E, all of the above. NDE technicians are usually qualified in accordance with the requirements of letter A, AWS D1.1, letter B, API 1104, letter C, ASNT SNT TC-1A, letter D, ASME Section 8, letter E, ASME Section 9. So let's run through all of the standards here. So AWS D1.1 is for structural welding. API 1104 is for pipeline welding for the oil and gas industry. ASME 8 is the boiler and pressure vessel code, while ASME 9 is the BPVC volume for welding, brazing. This is where the guidance for WPS, PQR, and WPQR are based on for pressure vessels, which leaves us to letter C, which is the standard in which these NDE technicians are qualified for. In GMAW, the type of metal transfer requiring a special power source is letter A, spray, letter B, globular, letter C, pulsed arc, letter D, short circuiting, letter E, open arc. So the type of weld, so the type of metal transfer for gas metal arc welding that requires a special power source is pulsed arc. So because it has to produce a direct current output to allow the welder to vary the combination of high and low current, thus a pulsed arc. So the answer here is letter C. Which of the following is considered to be the most portable method of magnetization when conducting a magnetic particle test? Letter A, AC coil. Letter B, AC yoke. Letter C, DC coil. Letter E, letter D, DC prod. Letter E, headshot. So the most portable method when conducting a magnetic particle test or MPT is the AC yoke because they come in lightweight units. So the answer here is letter B. Which of the following contains ferrous base metal specifications? Letter A, AWSD 1.2. Letter B, ASME Section 2, Part C. Letter C, AWS A 5.1. Letter D, ASME Section 5. Letter E, ASME Section 2, Part A. So AWS D 1.2 refers to structural welding of aluminum. ASME Section 2 Part C refers to the welding rods, electrodes, and filler metals. AWS A5.1 is for SMAW carbon steel electrodes. So normally for AWS A5, they refer to electrodes. The number just differs for the different welding processes there. ASME 5 is the NDE code, which leaves us to letter E. So the answer here is letter E. ASME Section 2 Part A refers to ferrous base metal specifications or metal specifications with iron bases. A welding process commonly used to join light gauge stainless steel tubing for critical applications is letter A SMAW, letter B GMAW, letter C gas tungsten arc welding, letter D OFW, letter E FCAW. Of all the processes mentioned, GTAW can join light gauge stainless steel tubing for clean or critical applications. So the keyword here is critical application. So that will mean that it will be required for example, very clean or food, beverage, or even oxygen applications that will be necessary for a clean or critical service. GTAW is commonly used for these process because they produce no slag and provides a clean weld unlike the other welding processes in the choices. So you can't use stick, for example, in this scenario because it will just produce slag, which you don't want in this instance. ET can be used to detect which of the following. So ET is eddy current testing. A. Material conductivity. B. Material hardness. Thin material thickness. Materials heat treatment, or E. All of the above. So eddy current testing or electromagnetic testing can measure conductivity, hardness, material thickness, and heat treatment condition. So the normal application of eddy current testing is used for example, evaluation of heat exchanger tubes by passing an inside diameter test coil inside of the tube, which reveals a host of defects if there are any. And these properties will be detected as well. So the answer there is letter E, all of the above. The marking of a rejectable weld should, letter A, be clear and understandable to all involved, be made with a steel impression stamp, note the proper repair procedure, always be in red, always include the welder's identification. So if an inspector is marking a rejectable weld, it should be clear to all stakeholders, which the answer here is letter A. So letter B might imply that it should be clear, but this does not mean that it will be clear for all. So still impression stamp can be erased in due time. For letter C, the repair procedure may or may not be determined immediately and will depend on the defects. Letter D does not make any sense there. Letter E, weld package does include some kind of a welder ID, which this choice refers to. So when a reject weld has been done, the welder can repair, but it's not marked. So it's on a different document altogether. So the answer here is letter A. A single V-groove weld always requires letter A, special welding processes, B, back gouching, C, backing bar, D, no root opening, E, CPJ unless otherwise specified. So CPJ or complete joint penetration is what is being meant here. So the answer here is letter letter E. So a single V groove always requires a complete joint penetration. An incomplete joint penetration can be done, but it has to be specified in the drawing. Heat treatment conditions can be determined using which of the following? Letter A, MT, letter B, PT, letter C, ET, letter D, RT, letter E, LT. So in this question, ET determines the heat treatment conditions of the metal by measuring electrical conductivity. So that electrical conductivity is a property that is affected during the heat treatment of the metal. Thus, ET can detect that condition or that property. Hence, it can detect the heat treatment condition of the metal. So the answer here is letter C. Incomplete fusion can be caused by letter A, not preheating, B, not filling the joint completely, letter C, improper gas shielding, letter D, poor fit up, letter E, excessive amperage. So incomplete fusion here is affected by poor fit up. So the answer here is letter D. As the misalignment caused by it leads to the base metal not being completely fused. If you don't properly align your two base metals, you'll not completely fuse the metal altogether. So preheating affects the grain structure and weldability. It affects the heat input. So you mainly use preheating for harder metals for it to be more weldable. Letter B, not filling the joint completely. So that's incomplete joint penetration. That's acceptable. It depends on the design. Improper gas shielding causes porosity and other discontinuity, but not incomplete fusion. Excessive amperage causes excessive heat input, and the tendency of it is melting the base metal, which is not incomplete fusion altogether. So the answer here is letter D, poor fit up. Developing is one of the steps in which NDE method. Letter A, UT and ET. Letter B, RT and PT. Letter C, PT and MT. Letter D, MT and ET. Letter E, VT and PT. The answer here is letter B, because RT, you need to develop the film in order for you to read the results, and developing is one of the process needed for penetrant testing. Hence, you spray the developer. That's how you develop that's how the results of the capillary action is being seen or observed. So the answer here is letter B. Which discontinuity below will provide the sharpest empty indication? Letter A, surface porosity. Letter B, surface crack. C, subsurface porosity. D, subsurface crack. E, indications will be identical for all of the above. Surface crack here provides the most abrupt, sharp discontinuity in the material, causing a severe disruption to the magnetic flux lines. So the other discontinuities here have more gradual profiles, resulting in weaker and less pronounced indications. So a surface crack will reveal the sharpest empty indication because of its abrupt disruptions of the magnetic profiles. So you can imagine that way. So if you have a surface crack, you just see an abrupt disruption on that profile. So the answer here is letter B. The other discontinuity will just have more weaker and more gradual profile altogether. Advantages of MT include letter A, detection of surface flaws, letter B, both AC and DC methods, letter C, detection of surface flaws tightly closed by carbon, slag, or contaminants, letter D, the fact that it's faster than PT, letter E, all of the above. MT can detect surface flaws. It can be done in both AC and DC methods. Detection of surface flaws tightly closed by carbon, slag, or contaminants. You can do that unlike PT. You need to clean the metal if you're doing penetrant testing there. And for that reason as well, it is faster than PT. So that will all be the advantages of magnetic particle testing. So the answer here is letter E, all of the above. Ultraviolet light may be used with which NDE methods? Letter A, VT and UT. Letter B, PT and UT. Letter C, MT and PT. Letter D, RT and UT. Letter E, ET and MT. Answer here is letter C, because ultraviolet light can make surface flaws stand out because it brightens up the indication or the discontinuity itself. The substance used in UT to aid in the transmission of sound from the search unit to the workpiece and back is called letter A, solvent, letter B, attenuation, letter C, couplant, letter D, cable, letter E, transducer. So the transducer is part of that search unit. solvent is not used here. Attenuation is just, it's a form of noise protection. Cable is part of that workpiece there, or no, so part of the search unit, I should say. Couplant is that fluid that is applied to the transducer that helps the transmission of sound waves similar to ultrasound imaging. So the answer here is couplant, letter C. Which process uses a granular flux that can be manually added to the weld pool? Letter A, SMAW, letter B, GTAW, letter C, ESW, letter D, SW, letter E, FCAW. So for the acronyms here, so SMAW is shielded metal arc welding or stick, GTAW is TIG, SW is slot welding, FCAW is flux core, so there's no manual flux in there. The flux is in the uh, electrode. So the answer here is electroslag welding, letter C. Because this is out of all the choices, this the welding process here that the flux is present and is manually added in the weld pool. So GTW has no flux. So yeah, you can almost rule that one out immediately. It is suspected that a GMAW weld has produced in an area where there was an excessive draft. Which non-destructive test would be best reveal the internal discontinuities which may have resulted? Letter A, PT, letter B, MT, letter C, RT, letter D, UT, letter E, none of the above. So excessive drafts can blow away or can remove your shielding gas altogether. This is just wind or air. So if that happens, you can have internal discontinuities here. So this question might be misleading. It may you may answer PT here, but the answer here is RT because you can remember the keyword here, internal discontinuities. Those internal discontinuities can be best revealed by RT because it's a subsurface flaw. This excessive draft can reveal internal porosities, which cannot be revealed by or will not be best revealed by surface detection methods like PTMT. UT is a bit much here. It's not like a thick metal that we're having to test here. So RT would be the best one to reveal the discontinuities because it will reveal the extent of the internal porosity. So the answer here is letter C. It should be letter C here. Which welding process utilizes a vertical orientation with welding occurring in the flat position? Letter A, ESW, letter B, SAW, letter C, SMAW, letter D, FCAW, letter E, OFW. So answer here is SAW or submerged arc welding. So this welding process is done in a flat position where a welding operator instead of a welder operates the machine and is usually an automatic process because the welding variables are not manually controlled. And it's a submerged process because you automatically provide or automatically input your flux in there. So you submerge basically the weld pool there with the flux. So the answer here is letter B. Which heat treatment process is primarily performed after welding to reduce residual stress without significantly changing the mechanical properties of the base metal? Letter A, annealing. Letter B, normalizing. Letter C, PWHT. Letter D, quenching. Letter E, carburizing. So let's discuss the choices here. So annealing softens the material, improves ductility, and refines the grain structure. So if you follow the question there without significantly changing the mechanical properties of the base metal, so annealing does that. So normalizing refines the grain structure and improves uniformity by heating above the electrical temperature followed by air cooling. So these heat treatment process is, for example, after you've heat treated the metal in an oven and you open the oven up, exposing the base metal to the atmosphere. So that's how normalizing is done. So you cool the base metal with air cooling. So it is not primarily performed as a post-weld stress relief treatment. Quenching is where it involves rapid cooling of the metal, which increases hardness mainly via quenching medium water or oil. So that will rapidly cool the metal, thus improving its hardness. You're basically making the metal more brittle. Carburizing is surface hardening process that increases carbon content at the surface. So that is not a relief heat treatment and is unrelated to typical post-weld heat treatment process. So the answer here is letter C, PWHT or post-weld heat treatment. So this process reduces the residual stress during welding, minimizes the risk of hydrogen-induced cracking because you're removing the residual stress from the heat input added through welding. It improved toughness and dimensional stability in some materials. And the holding time or soaking time depends on the material specification and applicable welding code. So the answer here is post-weld heat treatment. It doesn't significantly change the mechanical properties. It just removes those residual stress after the welding process. Which discontinuity is generally considered the most harmful because it can rapidly propagate under service loading. Letter A, porosity. Letter B, slag inclusion. Letter C, crack. Letter D, undercut. Letter E, spatter. So the answer here is letter C, crack. So this is the most harmful discontinuity because it doesn't have any acceptable limits. If you have a crack in the weld, that's an automatic defect. So it is considered as a linear discontinuity, creates severe stress concentration. So if you have a stress concentration, you'll have that will produce the maximum induced stress on that material. So almost all, or I don't know any welding code that has an acceptable limit for crack, but it is the most welding codes have or doesn't have any acceptable limits for crack, so it rejects. If you have a crack in the weld, that's an automatic rejection. Porosity reduces strength but usually less severe than cracks. Slag inclusion for stick welding or other process can reduce strength but is generally less critical. So these have an acceptable limit depending on the code. So undercut can be acceptable within code limits, and spatter is just merely aesthetic. So yeah, it'll you'll get away most of the time with the spatter. So the answer there is letter C, correct. Which electrode classification is used for carbon steel? SMAW. Letter A, ER70S6. Letter B, E7018. Letter C, E308L. Letter D, ER4043. Letter E316L. So the keywords on this question is carbon steel and SMAW. So what is the which of the following in the choices below corresponds to an electrode classification for carbon steel and stick welding? So if you see S here, that is solid wire. So that is used for gas metal arc welding or MIG and TIG. E308L and E316L is for stainless steel. So that's not carbon steel electrode. The 4043 or 40 series is for aluminum filler wire. So that's not carbon steel. So the answer here is E7018, letter B. That is letter B. Should be letter B. So this is a stick welding low hydrogen electrode because of the last digit there and one of the most common structural electrodes. Answer is letter B. The primary purpose of preheating before welding is to letter letter A, increase deposition rate, letter B, reduce cooling rate, letter C, improve arc stability, letter D, eliminate porosity, letter E, reduce distortion. So let's go through the choices here. So what is the primary purpose of preheating there? So increase deposition rate. So preheat doesn't affect the deposition rate. Deposition rate mainly depends on your travel speed and all that. Improve arc stability, so not necessarily. Eliminate porosity may help indirectly, but not that's not its primary purpose. Reduce distortion can be that way, but it's not the primary purpose of preheating. So the answer there is letter B, reduce cooling rate. So if you preheat the metal, so you there is a there is more heat input to it, thus reducing the cooling rate and thus consequently reduce the chances of that metal cracking or the weld metal cracking due to the difference in temperature you when it suddenly the weld metal becomes cooled because you reduce the cooling rate of that weld metal there. Which NDT method is capable of detecting internal discontinuities in weld? Letter A, visual. Letter B, liquid penetrant. Letter C, magnetic particle. Letter D, radiographic testing. Letter E, dye marker inspection. So visual, of course, it's only surface. That is limited to your naked eye. Letter B, liquid penetrant testing. So that is surface breaking defects only. The dye penetrant testing. Magnetic particle is surface and near surface only. Die marker inspection is not a recognized entity inspection, so you can automatically rule that one out. So the answer here is letter D, radiographic testing. So it can detect internal discontinuities like porosity, slag, lack of fusion, etc. So the answer there is letter D. Which weld consists of two members lying in approximately the same plane? Letter A, corner joint. Letter B, lap joint. Letter C, T joint. Letter D, butt joint. Letter E, edge joint. So a corner joint is L shape. Lap joint is an overlap between two joints. Letters letter C, a T joint is T shape. Edge joint is joining parallel edges. So a butt joint is same plane joined edge to edge. So the answer there is letter D, butt joint. Which shielding gas is commonly used for GTAW on stainless steel? Letter A, oxygen. Letter B, nitrogen. Letter C, argon. Letter D, carbon dioxide. Letter E, hydrogen. So you don't use oxygen for GTAW, for especially for stainless steel. It's too reactive. Nitrogen, you don't use it alone. Mainly used for purging. So it's commonly mixed with other gases. Carbon dioxide is mainly used for MIG. Hydrogen for very limited use only. So the answer here is argon. So that is the most commonly used for TIG welding, especially for stainless steel. Letter C. What does the number 70 indicate in the electrode designation E7018? Letter A, electrode diameter. Letter B, welding position. Letter C, tensile strength. Letter D, flux type. Letter E, current polarity. The first two digit there, let number 70 is the tensile strength in KSI. So the answer there is letter C. So in KSI, so that'll mean 70,000 PSI tensile strength. Which defect is most likely caused by excessive welding current? Letter A, incomplete fusion. Letter B, undercut. Letter C, cold lap. Letter D, lack of penetration. Letter E, slag inclusion. So the question there is which defect is most likely caused by excessive welding current? So that'll mean more heat input on the base metal. So incomplete fusion is normally resulted by low heat input, so that's not excessive welding current. Cold lap, similar, usually insufficient heat. Lack of penetration, same, usually insufficient heat or low current. Slag inclusion does not necessarily is related to heat input, but more of the technique or cleaning methodology of the welder. So the answer here is letter B, undercut. So that is resulted by excessive current, thus resulting to undercut, letter B. During visual inspection, which instrument is commonly used to measure fillet weld size? Letter A, micrometer. Letter B, dial indicator. Letter C, fillet weld gauge. Letter D, feeler gauge. Letter E, caliper. So let's go through the choices here. So which is commonly used to measure fillet weld size? Letter A, not intended for weld sizing. Dial indicator is usually measured for a displacement. Letter D, feeler gauge, measures gaps. Letter E is not a standard for weld gauge. So the answer here is letter C, designed for fillet weld measurement.